Hi, I'm Rob, and I'd like to welcome you to this Python Fundamentals video in the Python for Data Science and Machine Learning playlist on the Cumulus Cycles channel. Before we get started, I want to mention that, as the title of this playlist indicates, the videos in this playlist will focus on using Python in data science and machine learning applications. We won't be using Python for web development. Also, the videos in this series are geared more toward individuals with some prior programming experience, as this will not be an intro to application development. Now, with that out of the way, let's get started. Alright, here I am in VS Code, and like with other programming languages you may have worked in, I have a couple source code files in this directory. And since I'm working in Python, you could see they have .py extensions. I'll open the first one, and we see it's a simple app which prompts the user for their name, then prints the greeting to the console. To run this app, I'll jump into the terminal and execute Python in the name of the file, which happens to be one_app.py. We see I'm prompted for my name, and if I leave it blank and hit enter, we get a message, sorry, you didn't enter your name. Now I'll go ahead and run the app again. This time I'll enter a name, and we get the greeting, hello foo. And if we look at to_app.py, we see it's a similar greeting app, but this time when I run the program, it prints a message to the console that the usage is Python, the name of the file, and then you provide your name. So I'll run the app again, providing the name foo, and we get the greeting, hello foo. Now, the purpose of those demos wasn't really to review any Python code. It was just to show the traditional way of running apps, which I'm sure you're used to. However, when you're working with Python in data science, it's common to write your code in Jupyter notebooks, which use IPYNB files for interactive Python notebooks, as you'll see with the files in the notebooks directory. Now, I can run this notebook right in VS Code if I'd like, by selecting a Python runtime. As we see here, I have Python 3.12.7 from my Anaconda installation, then click into the cell and press Shift-Enter. At the top of the screen, I'm prompted to enter a name, so I'll enter foo and hit enter. Then click into the next cell, Shift-Enter again, and we see the greeting, hello foo. So that's one way of running your Jupyter notebooks. However, a more common way is to directly launch Jupyter Notebook in the directory which has your project files. So I'll go ahead and close VS Code. Then in my to_notebooks directory, I'll enter the Jupyter Notebook command and hit enter. And we see the Jupyter Notebook web interface. Now I'll go ahead and click the one_demo IPYNB file. And once again, click into the first cell, Shift Enter, enter a name, click into the second cell, Shift Enter again, and we see our greeting. Now going forward, this is the way that I'll present the demos in the video, using Jupyter Notebook directly and not using VS Code. Alright, now let's close this demo and launch the data type strings IPYNB file and start looking at some foundational Python code. In this first cell, I've declared a few variables. If you've worked with other programming languages before, I'm sure you'll notice that we have variables with string, integer, boolean, and float data types. I'll go ahead and Shift Enter to run the cell. Then in the second cell, we see several print statements. These are using the Python print format, which will print out the text, in this case, first name, then use the curly braces to inject the value of the first name variable, and then write out the data type for that variable by passing the variable name to the type method. Now, I'll go ahead and run this cell, and we'll take a look at the output. So here we see that the variable first name, which has the value foo, is of a type string. The last name with the value bar is also a string. Age has the integer 21. Is student is set to true, and that's a Boolean. The major of data science is a string, and the bookstore balance of 12.75 is a float data type. Since we'll be working with strings specifically in this demo, we'll move into the next cell and look at string concatenation. Here I've set the value of the first name variable equal to the string space biz space, and the last name is space space baz space space. Now what I want to do is strip the leading and trailing spaces by calling the strip method on the first name, then concatenating an empty string to the last name, which I'll also call strip on, and saving that value in the full name variable. Then we'll print the value. Another way of performing this concatenation is to use string formatting, where instead of concatenating the empty string, I strip the leading and trailing spaces from the first name variable, inject that into the string, have a space, and then inject the stripped last name, and print it out again. So let me run this cell, and as expected, we see the full name is biz space baz in both cases. As with other programming languages, we have additional methods we could call on the string class. In this case, I'm transforming the full name from biz baz with capital B's to uppercase and lowercase. In this next cell, I'm calling the split method on the full name and then printing it to the console. Then I'll write out that split name is of type, passing the variable split name to the type method, and we see that split name is of type class list. And here we see a Python list, which is enclosed in square brackets, with the first name being the first element and the last name being the second element. Now, although we'll take a deeper dive into lists and loops, I just want to show a simple example of looping through each character in a string. So here, I'll create a variable called position and set its value equal to 0. Then for each character in full name, what I want to do is print the position of the character. So the first position will be 0 since Python is 0 indexed, and then the character. If the position is equal to 0, I want to print this string with the left arrows and the message note the 0 position for the first character. Else I'll print an empty string and then increment the position. So I'll run this cell, and we see in the 0th position is the first letter of the first name and then the note indicating the 0th element. Then of course I is in 1, Z is in 2, and the space between the first name and last name is in the 3rd element. Scrolling down, and this next cell will work with string splicing. So first I'll print out the full name and inject the full name value and its length by passing the full name variable to the length method. So let's go ahead and run this cell, and then we'll come back and look at the slices. So the first output is full name, which is biz space baz, is 7 characters long. The next line grabs the 0th element from the full name variable, which we see is B. The next line grabs the element in the 6th position, which is the last position in the string, and we see the lowercase z. Now, we're using position 6 even though the string is 7 characters long because of the 0 indexing. The next print line says print full name starting at 0, colon, and then no value. So this says start at the 0th element and go to the end, and that's where we see biz baz. We could do the same thing by starting with the 0th element and going to 7. Now, even though we only have 6 characters, this will grab the 0 through 6, excluding 7. And again, we see biz baz. The next print statement says start at 0 and go to 3. So here we see 0, 1, 2, which is biz, skipping 3, which would be the space. If we want to grab the space, we can say full name 3. And here we see the space. And the last print statement says start at the 4th element and go to the end. And we see the last name. The last demo will be to find a character in a string, or the character's position. So here I'm declaring a variable characters, and I'm calling the find method on full name passing the uppercase B, and then printing out characters. And again, this is actually the position of the character. And when we're executing find, it's the first position that the B is found in. So even though full name has two uppercase B's, it'll find the first one and then print that value. So let's go ahead and run this. And we see that the first B is in the 0th position. When we call rFind, it will find the last or the furthest from the 0th element for the position of the B. And in this case, we see it's in the 4th position, where we would expect BIZ space and then B in the last name. So although those were just a few examples of working with strings in Python, we'll have plenty more examples of working with strings as we move forward in the demos. Now let's go ahead and close this notebook and launch the numbers demo. Alright, so in this example, I'm once again declaring some variables. With first and last name, which are strings, there's an age, which is the string 21, is student is true, the bookstore balance is the string 12.75, and meal credit is equal to the string T. So I'll go ahead and run this cell, and then run the second cell and print the data types, which as we just discussed, are strings, Boolean, and more strings. So in this next cell, I want to take the string 21 and pass it into the int method and cast that string into the number 21 and store it back into the age variable. And I want to do the same thing with the bookstore balance, which is the string 12.75, cast to a float and store that as well. So I'll go ahead and run this cell. And now we see age 21 is an int and the bookstore balance is a float. Here, I want to try and take the meal credit, which is currently the string T, and cast that into a float and then print its value. When I run this cell, as I'm sure you would expect if you have prior programming experience, we get an error that we could not convert the string T into a float number. So I'm going to use that example as an opportunity to introduce error handling in Python, where we have a try except block. Now if I scroll back up again, we'll see that the type of error that I had was a value error. So I'm going to try to once again cast the string T into a float, but that's going to throw the error exception of type value error, which I'll catch and then print the error message instead of seeing this error. So I'll go ahead and run this, and now we see our expected message versus an exception being thrown and stopping program execution. In this next demo, I want to work with random numbers. And to do that, I'll import Python's random module. Then I'll create a variable called rand and set it equal to calling the random method on the random module, which will return a number between 0 and 1. Then I'll print the value. In this code, I declare a Python list named rand numbers and a min and max value, which will be used in this for loop. So for the variable I in the range between min and max, where the min is 1 and the max is 11, and range will include everything from the min up to but excluding the max of 11. So basically this is 1 through 10. Each time through this loop, append to the rand numbers list the result of calling the rand range method on the random module and passing the min and the max values. So this will return a random number between 1 and 10. Then I'll print the results after the loop finishes execution. So I'll go ahead and execute this cell, and we see our random number 0.7927 and so on, and our 10 values between the range of 1 and 10. Now let me go ahead and run this again. We see a different random number and a different list of random numbers. Now in data science, you'll often hear the terms population and sample, where population represents all the values in your data set. So in this case, I have a population of 10 values, each within the range of 1 to 10. A sample is a subset of the population. So what I can do to get a sample of this population is call the sample method on random, passing it the random numbers, which we see here, and asking for 5 values. So when I execute this, I see 5 random values from the population. If I run this cell again, I get a different set of values in the population. And if I run this cell, of course I'll get 5 different numbers in the sample from the population. Scrolling down to the next example, I've declared 2 Python functions. The first is calcsum, which takes a list of numbers. The code calculates the sum and then returns the value. CalculateAverage also takes a list of numbers, which will return the average of the numbers. And it uses the calcsum function to calculate the sum before dividing by the length of numbers which were passed in. So here, I'm calling the calcsum function passing the sample, and the calcaverage function, again, passing the sample. So I'll execute the code in this cell, and we see the sum of the sample numbers is 19, and the average is 3.8. This next example finds the median, or the middle value of the sample. So here I'm passing sample into the find median function. Then I check to see if not numbers. So if no numbers were passed in, I'll raise this value error. If I do have numbers, then the first thing I want to do is call sorted passing the numbers. This will create a sorted copy of the numbers that were passed in, stored in the sorted numbers variable. Because in order to find the median, or the middle number in the range of sample values, we need to sort them, low to high. Then I'll get the length of the sorted numbers. If I have an odd number of sorted numbers, then I could just divide the length by 2 and get that value's index from the sorted numbers list. If I don't have an odd number, then I need to find the middle 2 numbers in the list, calculate their sum, and divide by 2. So here, if I execute the code in the cell, we see that the median of the sample numbers, 6, 4, 3, 4, and 2, is 4. Because if I sort this, 2 will be first, then 3, then 4, then 4, then 6, with the middle being 4. In this last example, I want to get a sample of 6 numbers from the random numbers population, which I'll then print and then pass the sample to the find median. And the reason that I'm doing this is because we have an even number of values in the sample, so we fall through the else statement. And we see the median of the sample numbers, 8, 2, 3, 7, 4, 5, is 4.5. So that concludes this demo on numbers. Let's close this up and open the list demo. In Python, lists are ordered, mutable collections that allow duplicate elements and are accessed by the index of the elements in the list. So to get started, I've created a variable named fruits. Its type is of list because it starts and ends with square brackets. Inside, we see I have 3 strings, cherry, apple, and banana. So if I were to print fruits is of type, passing fruits to the type method, we should see list. Then I'll print the length of the list by passing fruits to the length method, and then I'll call sort on the fruits list to sort them alphabetically, and then print them again. So let's jump down and execute this cell, then we'll come back and look at the rest of the code. So in the output, as expected, we see fruits is of type list. There are 3 fruits or 3 elements in the list, and the sorted elements in the list are apple, banana, and cherry. Jumping back up in the code, if I want to get all of the elements in the list, I could start with the 0th index, add the colon with no stop value, and we see I have all the elements printed. Also, since I know the length of the list, I could start at 0 and go to 3, and again, we see all the elements. If I just want to grab the first element, I could indicate the 0th index. And again, since I know the length, if I want to grab the last element, I can pass the index of 2. Jumping down to the output, we see the first element is apple and the last is cherry. Now, since lists allow duplicate values, I'm changing the value of the fruits list to cherry, apple, banana, and a second apple. I'll print the list, sort, and then print again. So looking at the output, we see the original list of cherry, apple, banana, apple, and then the sorted list has the 2 apples first. Back in the code, I'm going to change the 3rd element in the list, which again, if we look at the output, is 0, 1, 2, 3. So from cherry to mango. And we jump down to the output, we see cherry has been changed to mango. And finally, I'll call the remove method on the fruits list, passing mango and printing, which gives us the output of apple, apple, and banana. In this next example, I'm resetting fruits to cherry, apple, banana, and apple. I'll print the fruits and print the count of apples in the list. So let's execute this code. We see our list of string values and that there are 2 apples in the list. Then I'll call the remove method, removing apple from the list, and again, printing the count. So here, after removing apple, we see cherry, banana, apple, and that there is 1 apple in the list. Now I'll sort the fruits list and then loop through it. So for each fruit in the fruits list, print the value of the fruit. So if we jump down, we see the first time through the list we have apple, banana, and cherry. Finally, for this cell, I'll call the clear method on fruits and then print the list, and we see we have an empty list. For this last example, I'm declaring 2 variables of type list, one for odd numbers, the second for even. Here I have a for loop, so for the variable I in the range from 1 to 11, which as we discussed, the 11 is excluded, so this will give us a range of numbers from 1 to 10. Then I'll use the modulus operator to see if the number is even or not, and if it's even, I'll append the value of I to the even list, else I'll append the value of I to the odd list. Finally, I'll print the odd and even lists. So let's go ahead and execute this cell. And we see the odd list has 1, 3, 5, 7, 9, and the even list has 2, 4, 6, 8, 10. Jumping back up at the code, what I want to do is create a variables number, and I want to concatenate the odd and even lists. So this should give us a list of all the odd and even numbers in the order that they were added to the odd list and then the even list. So looking at the output, we see this numbers list contains 1, 3, 5, 7, 9, then 2, 4, 6, 8, 10. Finally, I'll sort the list and print it again. So now we have the numbers 1 through 10 in the sorted order. All right, with that, let's close lists and open tuples. So in Python, tuples are an ordered, immutable collection that allow duplicate elements, again, accessed by an index. So to get started, here I've declared a variable named fruits. Its type is of tuple because it starts and ends with parentheses, and inside has the value of 3 strings, apple, banana, and cherry. Next, I'll print the fruits, and that fruits is of type, in this case, tuple, and that there are len fruits in the tuple. So let's execute the code in this cell. And looking at the output, we see apple, banana, and cherry, that fruits is of type tuple, and that there are 3 fruits in the tuple. So back in the code, I'll change the value of fruits to apple, banana, cherry, and add a second apple. Again, print the tuple and that there are, in this case, 2 apples in the fruits tuple. And if we look at that output, we see that apple has been added a second time and that there are 2 apples in the tuple. And finally, I'll print the values of the tuple from 0, with no stop, and we see we have all the values in the tuple. In this next example, I've declared a variable named student. Again, it's a tuple, but this time it has mixed data types. So let's say that the first element, foo, is the student's first name, bar is the last name, 21 is the student's age. There's a boolean set to true, which indicates that this person is a student. The student's major is data science, and the student has a bookstore balance of $12.75. So let's go ahead and print the tuple, and we see our values. In this next cell, I've defined a function named display major that takes one parameter named the student. And I'll check to see if the string undeclared is in the student. If it is, I'll print a message to the console with the student's first name and last name has not selected a major. Else, if undeclared is not in the student, I'll print that the student is a data science major. So on this line, I'll call the display major function, passing the student that we declared in the cell above. So let's go ahead and execute. And as expected, we see that foobar is a data science major. In this last example, I have a variable named people. It's of type list. Note the open and close square brackets. And each element of the list is a tuple. So what I want to do is loop through the list of people. Each time I'll declare a person. Then I'll go to the fourth element in the person and grab the Boolean indicating if this person is a student. And if the person is a student, I'll call the display major function passing the person. Else, I'll print a message that the person is not a student. So let's go ahead and execute this. And for the first tuple that's passed in, we'll see that the isStudent Boolean is set to true. So when this is passed to the display major function, we see that foobar is a data science major. In the second element in the list, this tuple also has a Boolean indicating that the person is a student, but the major is undeclared. So looking at the output, we see BizBaz has not selected a major. And finally, the last element in the list, the isStudent Boolean is set to false. So the output indicates that Bing Bang is not a student. All right, let's close tuples and open sets. In Python, a set is an unordered mutable collection of unique elements useful for membership testing and mathematical set operations. So let's take a look at some examples. Here I've declared our familiar fruits variable. Its value is a set of strings. And we know this is a set because it has the open and close curly braces. Then, as usual, I'll print the fruits, its type, and the length. So let's execute this. And as expected, we see the value of the variable, that fruits is of type set, and that there are 3 fruits in the set. Next, I want to traverse the values in the set. So for each fruit in fruits, print the fruit. We'll execute this, and we see apple, cherry, and banana. Next, what I want to do is add mango to the fruit set. And now we see mango was added as the first element. Here, I want to print if apple is in fruits, which we know it is, and if pear is not in fruits, which we know it is not. So let's execute the code, and we see that the statement apple in fruits is true, and pear not in fruits is also true. In this next example, I've declared a set 1, which has 1, 2, 3, 5, 6, 7, 9, and set 2 with 2, 4, 5, 6, 8, 9, and 10. Set 3 is the difference between set 1 and set 2. So I'll go ahead and print set 3. Let's run this code. And here we see that the difference between set 1 and set 2 is the set of 1, 3, and 7. Because 1 is in set 1 and not in set 2, as is 3 and 7. For set 4, I want to print the intersection of set 1 and set 2. So which values are in both sets? And we see 9, 2, 5, and 6. Is looking at set 1, we see there's a 9, and also in set 2. Set 1 has a 2, as does set 2, and the same for 5 and 6. In this last cell, we want the union between set 1 and set 2. So let's go ahead and execute this cell. And we see the union contains all the values in the sets, excluding duplicates. So for example, we see there's a single digit 1 and a single digit 2. Looking at set 1, we see there's a 1, and there is no 1 in set 2, but both sets 1 and set 2 contain 2. Next, I'm going to check to see if set 4, which was the intersection of set 1 and set 2, is a subset of set 5, which is the union of the two sets. And that results in true. Then I'll check to see if set 5, which contains the union of both sets, is a superset of set 4, which contains the intersection, and again, that is true. All right, we're moving along here, so let's close sets and open dictionaries. Dictionaries are unordered, mutable collections of key value pairs, where keys are unique and they're used to retrieve associated values. So looking in the first code cell, I've declared a variable student. Its type is a dictionary with key value pairs. So the student has a key of first name. Its value is the string foo. It has a key of age. Its value is 21. True is the value for the key is student, and there are keys for major and bookstore balance. So I'll go ahead and execute the code in a cell, and here we see I print the student, and we see the key value pairs, and that student is of type dictionary. Next, what I want to do is access the student dictionary and set a new key with the value of 123.25 and then print the student. So here we have the updated dictionary and we see the key meal credits with its value. In the next cell, I just have a simple print statement where, again, I'm accessing the student dictionary by a key to get the value. So if I execute this, as expected from the key value pairs in the student dictionary, we see that Fubar is majoring in data science. And finally, I just want to have a demo of printing and accessing the keys in the dictionary. So let me go ahead and execute this. In this first line, we see that the keys, which I got by calling the keys method on the student dictionary, is a list of the keys. Then I have a loop for each key in student keys, print the key name, and then pass the key into student and get its value. So here we see the list of keys and values. And that's it for dictionaries. So let's close this. And now we'll move into some math demos. To get started, I'll import the math and random Python modules. Then for the rest of the demos, I'll focus on calling built-in Python methods as well as methods from the math and random packages related to mathematical functions. First, I want to check to see if the string 2 is a digit. And if you've worked in other programming languages, I'm sure you've guessed this will return true. Calling isDigit on the string TWO will of course return false. This line will convert the string NaN to a floating point value representing not a number. And then it'll use the math is not a number method to check to see if the value is in fact not a number, which we would expect to be true as well. Then finally, I have a try except block, which will throw an exception because passing 2 to float will not return the floating point value representing not a number. And we'll jump into the exception block. So let's go ahead and execute this code. And we see that the string 2 is a number, the string TWO is not a number, that passing the string NaN to float is not a number. And here we have an error indicating we could not convert the string TWO to a float. In this next cell, I have code that uses methods from the math module. In this case, we want to raise 4 to the power of 2. We want to find the square root of 16, the ceiling and floor of 1.4, and the value for pi. Of course, we see 4 squared is 16, the square root of 16 is 4, the ceiling of 1.4 is 2, the floor of 1.4 is 1, and the value for pi. In this cell, we'll work with random numbers. So I've declared a random number variable. Its value is equal to an empty list. I have a rand minimum value of 0 and rand max of 500. So I have a for loop in the range of passing random minimum and random max to the rand int method on the random module. Then I have a variable number, which is equal to, again, passing random min and random max to rand int, and then I'll append this random number to the random numbers list. And finally, print the length of random numbers between the min and the max. Then the random numbers themselves. So let's execute this. And we see we have 464 random numbers between 0 and 500. If I run this again, now we have 381. In this next cell, we have code to find the min and max values of the random numbers, which we see are between 1 and 500. The final demos for math will calculate the mean, which is the average of the random numbers, the median, which is the number in the middle of the random numbers, and the mode, which is the most frequently occurring number in the random numbers. These are common values used in data science. So here, to calculate the mean, I have a calcMean function, which takes the numbers. I'll get the sum of the numbers divided by the length of the numbers if I have numbers passed in, else I'll set the mean value to 0 and then return the mean. So this line will print the mean is equal to passing the random numbers to the calc mean. So I'll execute this code, and we see the mean or average value of the random numbers we generated above is 257.695. Find median takes the numbers and then sorts them, because in order to find the value in the middle of the numbers, we need them in a sorted order. Then I'll check to see if we have an odd or even number of random numbers. If we have an odd number, we can simply get the length divided by 2 and then access the result of that index in the numbers list. If we have an even value, we need to get the two numbers in the middle, calculate their sum, and then divide by 2. And then finally return the median value. So if I execute the code in this cell, we see the median is 259. And then finally, the function which finds the most frequently occurring number, or the mode of the value in the list, will take the numbers, convert them to a set, and then pass the set and the key, which will be equal to the count of values in numbers, into the max method. Then return the mode. So we'll execute this cell, and we see the most frequently occurring number in our random numbers list is 74. So that's it for the math examples. We'll close this and open up the final demo, which is object-oriented programming. Okay, in this demo, the first thing I'm going to do is import the CSV and pretty print modules from Python. Then I'm declaring a class of person, which will represent a person with basic details. So here I have the constructor function, which takes self, a first name, which is a string, which defaults to an empty string. We have last name and email. Then I'm setting the first name, last name, and email properties to the values that were passed in. So let's go ahead and run this cell. And now we have declared a person class. In the next cell, I'm declaring a class of student, which is a subclass of person. The constructor function takes self, a student ID, which is an integer defaulting to 0, the first name, last name, and email, as well as a university and a major. And if a major isn't passed in, it'll default to undeclared. Then in the constructor function, the first thing I want to do is call super. So I'm calling the constructor function in person, which is the superclass of the student, passing the first name, last name, and email. So this line of code will instantiate an instance of the person class. Then back in student, I'll set the student ID, university ID, and major values equal to what was passed in when creating a student object. Then I'm setting a private property of GPA to 0.0. So GPA isn't passed in to the constructor function when declaring a student, so I'm setting it here. Then I have additional properties, which are functions, to set the university, set the major, set the GPA, and get the GPA. So I'll go ahead and run this cell, and now we've defined a student. This next cell is going to load student data from a students.csv file. So let me open that file and show you what's in there. And it's a simple CSV with student ID, first name, last name, email, university, and major. So let's jump back to the code. And with the student CSV file open, we'll read the contents in. And for each row in the reader, we'll create a dictionary containing the values from the CSV file. Then for each row, we'll append to the student data list the student dictionary, and then return student data. So let's go ahead and execute this code to load the load student data function. All right, so here we have a variable called student data. Its value is going to be the result of calling the load student data function, which, as we just saw, will open the CSV file, read through the rows, create the student dictionary objects, append them to the student data list, and return the list. So we'll run this and then pretty print the student data. And we see we have a list of 3 dictionaries with the data from the CSV. Now let's scroll down and declare a function to create student objects, which will take a student and then return, calling the student constructor function, passing the values for student ID, first name, last name, university, and major that we read in from the CSV file. So let's go ahead and load this function into memory and then declare a list for students. Now, for each student in student data, we want to append to the students list the result of calling create student objects, passing the student. And then for each student in students, we'll print the first name, last name, the major, and the university. So let's go ahead and execute this. We see that Fubar is majoring in data science at Harvard, which we see in the first row. BizBaz is majoring in blank at blank, which we see there's no university or major passed in for the second row. And at Bing Bang is majoring computer science at MIT. So what I want to do now is update the major and university for BizBaz, which is the second element in this students list. So I've created a variable to hold that data, and now I'm going to call the set major, set university, and set GPA methods on the student class. Then I'll print the results of setting those values. And now we see BizBaz is at Yale Law School, majoring in law, and has a 3.9 GPA. But these values are only updated for this variable. They're not updated in the students list. So now I'll directly set the values in the students list at element position 1 by calling the methods on the student and setting them equal to the values, which are the properties of the Yale student variable. And if I do that, we see the variables have been set. And if we once again loop through the students list, we now see BizBaz is majoring in law at Yale Law School. So that concludes this video on Python fundamentals. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching, and I hope to see you in the next video in the playlist.